Alright, reflex number 11. Reflex 11 is translating graphs of functions. So the rule is y is equal to f of x plus k shifts the graph up k units when k is greater than 0. So here, given this graph of f of x, if there is a translation of plus k, that means that we're going to have an upward shift of our graph of k amount of units. So this next rule is y is equal to f of x minus k. It shifts the graph down k units. So here is our function of f of x. And if we have a translation of f of x minus k, that means it's going to go downward k amount of units. Alright, let's take a look at this example. So here we have a function of f of x is equal to x squared. So if we have a plus 2, so that means it's going to be going up 2 units. So it's going to land from 0, 0. It's going to go up 2 units, so k is equal to 2. Here you can see f of x is equal to x squared minus 5. So this minus 5 means that it's going to be going downward from our original function. So it's going to land on negative 5 from starting off from 0, 0, my origin. Alright, in this slide we're going to look at this rule where we have y equals to f of x plus k. It shifts the graph left k units when k is greater than 0. So here we have our original function, f of x, and if there's a shift where it's f of x plus k, this plus k means it's going to shift to the left that k amount of units. The next rule states that we have y equals f of x minus k. It shifts the graph right k units when k is less than 0. So we have our function f of x, and if we have a shift that's going to the right, or a translation of f of x minus k, is going to shift to the right k amount of units. Let's take a look at our first example. So given this function f of x is equal to x squared, we're going to have our first shift where it's inside the parentheses, f of x is equal to x minus 2 squared. So that means it's going to shift to the right to positive 2. So it started with my origin 0, 0, and it shifted to the right 2 units. So now we have positive 2. We have a f of x is equal to x plus 5 squared. This is meaning that it's going to shift to the left from our original function. Okay, so you can see from 0, 0, it's going to land at negative 5. Let's take a look at this example. We have draw the graph of the function f of x is equal to square root x minus 3 plus 3. So we have this original function, which is our parent function. F of x is equal to square root of x. So we do our what's inside the radical first. So we have f of x minus 3. So that means we have moved to the right 3 units. So from 0, 0, it's moved to the right 3 units. Now we're going to do this. This is my first one, and then now we're going to do this step as my second. We're going to add 3, but that means we're going to move up 3 units. So we've gone 3 to the right, and then we have go up 3. So then that is our complete transformation. All right, let's take a look at some exercises. So number 1, what is the function g of x after the transformations such that shifting the graph 2 units to the right? Well, if we have g of x as my original, if we're shifting 2 units to the right, that means we're going to have a shift inside my parentheses, and it's going to be a minus 2. So we have g of x minus 2. Problem number 2. It says here, let f of x equal the function x squared minus x plus 2 if g of x is a translation of f of x, which has been shifted left by 3 units, and shifted up by 4 units. What is the y-intercept point of the graph of g of x? So we have our function, and we want to find the g of x. So we're going to start off with showing that we have left 3 units. That means that inside is going to be plus 3. That's inside my parentheses. And then we have up 4 units is going to be plus 4 on the outside. So then therefore my function of f has translated left by 3 units and then up by 4. So now we're going to substitute this into my x value of my function, and then let's evaluate. So g of x is going to equal to, we have x plus 3 squared minus x plus 3 plus 4, and then plus 2 at the very end. Okay, so now I'm just going to simplify this a little bit. So we have g of x is equal to, we have x plus 3 squared minus x plus 3 plus 6. Okay, so now when we're looking for my y-intercept, that's when x is equal to 0. So we can actually just plug this in. We have g of 0 equals 2, and then this is going to be 0 plus 3 squared minus 0 plus 3 plus 6, and now we could just evaluate. Well, this is going to give me 3 squared, that's going to give me 9, minus 3, and then plus 6, so then that's going to leave me with 6 plus 6, so then g of 0 is 12. So my y-intercept is y is equal to 12. Okay, so then that's one method. My other method is a little bit of a shortcut. So we know that we have my g of x function that's equal to f of x plus 3 and then plus 4. So actually, we know that x is equal to 0 for my g function for the y-intercept. So we can just plug that in directly, and then that's going to substitute into this x as well. So we have f of 3, because this will be 0, plus 3, which is 3, plus 4. So now we can substitute this 3 directly into my f of x function. So we can have g of 0 equals to 3 squared minus 3 plus 2 plus 4. And then we can just evaluate this. So we have g of 0 equals to 9 minus 3 plus 6. So then that's also going to leave me with 6 plus 6, which is my y-intercept is equal to 12.